Welcome to this video where I'm going to talk about the science behind coffee. Or more specifically, I'm going to talk about caffeine. So the chemical structure for caffeine you can see here in my coffee cup, and the official name for it is 1,3,7-3-methylxanthine. Nowadays, people, like around 80% of the population, has a caffeinated drink every day. This doesn't necessarily have to be coffee, as you will see. Also, certain teas will contain caffeine, and even your chocolate. Now, the history of tea goes back way further than that of coffee. Thousands and thousands in BC, a Chinese emperor Shennong, he brewed the first tea by boiling in leaves with his water. So that's thought to be the first tea. The first coffee, that didn't appear until the 9th century in Ethiopia, when a goat herder noticed when his goats were eating the wild coffee berries, which you can see the picture of here, is that they started to become more alert and more active. And that gives you that effect that you know after coffee that you become more active, which is what caffeine does to you. However, the first drinks that were based on caffeine were not commercialized until the 1800s with Dr. Pepper. So you will see that also soft drinks contain an amount of caffeine. And here is to show you what other drinks contain caffeine. You'll be very familiar with espresso, where you have a high amount of caffeine, but remember it's only a small cup. You have your normal coffee, and then brewed teas, even they, most of the case, unless you use some herbal teas, they will contain a certain amount of caffeine as well. But you will see it's considerably less compared to espressos. And now what's interesting, a lot of your chocolate will also contain some caffeine, and I will explain a little bit more about why that actually is. So if you've got really dark chocolate that has that really bitter taste to it, and actually caffeine would have a bitter taste as well. So within chocolate, you do have some caffeine if you've got dark chocolate and milk chocolate. White chocolate, remember, you don't use the cocoa beans, so in that case, you wouldn't have any caffeine in there. Now, the main component in chocolate is theobromine. So if you look at the structure of caffeine on the left, theobromine on the right, you will actually see that they're quite similar. So where they are different is that if you look at what I've circled in the group, so theobromine lacks one methyl group, but they are still quite similar, so you might imagine that it might have similar effects as well. And you can see that dark chocolate, you have a lot of amount of theobromine, but you also still have a considerable amount of caffeine to go with it. And if you remember, we had these wild coffee berries who had this kind of reddish color to it. But obviously we know that coffee is brown, so it's quite different to what we would see there. Now, the roasting process, definitely from a chemistry perspective, is really interesting. And there are a couple of reactions that take place to give it that brown color. Now, if you look back to my video, which I did on baking a cake, you know when you bake a cake as well and you start to caramelize it, you have similar reactions that are occurring, and these similar reactions are the ones that are producing flavor. Now, there are two reactions that take place that actually give it that brown color. So at around 150 degrees, you get the Maillard reaction, and that produces a range of brown polymers. So I can go into a lot of detail here, but more information you can find on that specific one here. And then you also get caramelization of the sugars that in addition give it that brown color. This Maillard reaction is actually not just one reaction, you got a lot of reactions that take place. And depending on how long the roasting takes, you can actually tailor the process. So you can make some more fruity, you can make some more acidic. And here I've shown some of the chemicals that are involved with giving you specific flavors. So the roasting process is really important for how you produce the flavor from your coffee. But what does caffeine actually do in your body? So why does it give us that feeling of alertness? Now, you should know that in your stomach, around 90% of the caffeine, which is in a cup of coffee, is cleared in 20 minutes. So it means it will take effect of about 1 hour, 1.5 hours when you got that peak concentration of caffeine within your plasma. Now, what caffeine does, if you look at the structure of caffeine, you will see that it's very similar to adenosine. So the difference here is, I've indicated like in blue, you can see that these factors almost overlap. Besides the fact that adenosine, which is also in your DNA, it has got a ribose, so it's got a sugar group. But because the ring structure is quite similar, it means that caffeine also has potential to bind to specific receptors for adenosine in your body. And that particular compound is related to tiredness. So it means that if you get rid of that particular compound, that would give you a more feeling of alertness. Besides that, caffeine also has an important role in wastewater. And that's something that you probably don't think of, but I'm sure that all of you at some point would pour some coffee down the drain. And that's why we're seeing that the levels of caffeine in wastewater, they can be quite high. And they tend to be quite high if the wastewater treatment system is not working optimal. If it is, most of the caffeine would actually be cleared. So we can use caffeine as a marker for water quality. Because if the caffeine is there, it usually means that the wastewater treatment is like suboptimal. So it kind of indicates that there might be presence of other microorganisms. And to that extent, even within the Swiss lakes, which you can imagine is probably the purest water that we've got in the mountains, even there they found amounts of caffeine. And while caffeine itself is not particularly hazardous to us, I think you might remember theobromine when you think of chocolate and dogs, that animals, that their metabolism of theobromine is a lot slower, which is why chocolate is not hazardous to us, but it is to certain animals. Caffeine can also have some impact on aquatic life. So particularly if you've got certain mussels that need to adhere to the surface, caffeine makes them inflamed, so they're easier. What might happen is that they might easily detach. So even though the presence of caffeine in wastewater is probably not the most hazardous compared to some of the other compounds or heavy metals that you might have in wastewater, it certainly has an impact on aquatic life. And what we've been looking at, we've been developing a polymer-based system. So for the polymer, you can find more information here, to pinpoint like the amount of caffeine into wastewater using something very simple based on thermal analysis. If you have a barista preparing your perfect cup of coffee, you will know that it always tastes very different than it does at home. And that's because the coffee really, there's a lot of physical and chemical parameters involved. So these years in training really pay off in making sure that you can make your perfect cup of coffee. But in general, there are three things or factors that influence how your coffee would taste. And the first thing is the water chemistry. So coffee in itself is acidic. So these acids give it flavor. And I don't know if you know what hard and soft water is, but you can imagine if you had like very hard water, you have a lot of carbonate ions in there that what you might notice of is that they might mess with your washing machine where you get a lot of deposits there. So if you've got like water which is very hard, where you've got lots of these carbonate ions, which are bases, they can react with the coffee which is acidic, so they can take away some of the flavor that you might get. On the other hand, if you don't have a lot of these carbonate ions, then your coffee might taste a little bit sour because it's too acidic. So in general, what you want to have something which is nicely in between. Now, I don't have to talk about the grinding process, but I think you can imagine that the particle size distribution will also have a big influence on how the flavor is released. So the grinding is definitely a crucial step in preparing your coffee as well. Now, the last one is a very simple thing you can do at home, and this relates to the freshness of the coffee. Within the coffee itself, and I've shown you some of these flavor compounds which tend to be volatile. You even have carbon dioxide within your coffee. These flavors and compounds, they can escape over time. So sometimes you might see that people actually chill the coffee, but the easiest thing you would have to do at home is just use an airtight container to store those and to make sure that these compounds will actually give it that lovely flavor, that they don't escape from the coffee. So this was a quick summary on how in general how caffeine works, what are some of the important chemistry aspects, and some of the things that you might want to consider when preparing your perfect brew at home. So I hope you enjoyed this video, and within the next couple of videos we're going to give much more information about food science and the chemistry behind that.